Hey guys, so we're back. This is question 5 and question 6. The question's asking, so we have this matrix A, and it's the size of 3 by 2. We have this matrix B, it's the size of n by m, just random variables I'm using. And we have a matrix C, which is size 4 by 5. I'm just going to write down the transpose of that is going to be the opposite, right? So it's going to be 5 by 4. Um, Another thing I want to point out is that these are the columns, and these are the rows, right? One thing we want to know about a matrix when we're multiplying matrices, we can only multiply if the columns. So if the columns of B equal to the rows of A. In the sense, we can even say like if the rows of first matrix equal the columns of second. Okay? So this is our first matrix, and that way we know what n is, right? So we know B is equal to a 2 by something matrix. Now, it's saying A, B, C times a C transpose. Now, that means that the row of C transpose, which is the row C transpose, the row of C transpose of B, which is M, has to equal the columns of C transpose, which is 5. So it's going to be a 2 by 5 matrix. So our answer for this question is B. Now moving on. So for question 6, we're given the questions. It asks find conditions on A and B so that the system has only one solution. When I want to start this question, what does one solution actually mean? It means when I reduce this matrix, an augmented matrix, down, that, let me just write it down. So I'm going to write the augmented matrix. We have 1 plus B equals to negative 1, right? Then we have 2A plus 2 is equal to 5. And that's our augmented matrix. What that means is, the first thing to find any solutions is we have to get into row reduced echelon form. And let's do that first. So what I'm going to do is, I'm going to do negative 2A times R1 plus R2 changes R2. What does that give us? Well, this is going to stay how it is, right? This gives us over here a 0. And over here it's going to give us a negative 2AB plus 2, right? Negative 2AB plus 2. And over here it's going to give us a negative 2A plus 5, I think. 2A plus 5, right? So that's good, right? That's good. We had 2A this times that, and we just added that. Okay. Now I'm going to reduce it even further. What we're going to do now is I want to get rid of this B in this area. How I get rid of that B is first I'm going to divide out, make this a 1. Right? That's one of the things we learned in the previous videos. Negative 2AB plus 2 multiplied, so 1 over that, multiplied by R2 changes R2. So we actually get 1B, negative 1, 0, 1, 2A plus 5 over negative 2AB plus 2. Now, okay, so we've gotten this far. We're almost done. Now we're just going to do B, okay, negative B plus R times R2 plus R1 is actually going to change R1. Okay. So what do we have now? What do we have? We have a 1, a 0 here, right? Because this adds a negative 1. Right, this is pretty messy. So I'm just gonna put dotted lines just to separate these columns. Here's a 0, here's a 1. We still didn't change this, so it's gonna be 2A plus 5 over negative 2A B plus 2. And this is gonna be negative 1, right? Negative 1 times all this stuff, right? Plus 2a plus 5, okay, negative 2ab plus 2, all times negative b. I know it looks like a mess, but we can literally clarify this in a sense where, if you understand, we know that x has to equal, the top here has to equal negative 1 plus 2a plus 5, right? All over negative 2ab plus 2 times negative b, right? But the y has to equal 2a plus 5 over negative 2ab plus 2. And I'm going to take the negative 2 out from the bottom, right? Or I'm just going to take the 2 out from the bottom. And what that's going to give us is a 2a plus 5 over 2 over negative ab plus 1. Now if we go back to our questions, it gives us a couple of options. Which really stood out to me the most was B. The reason being is if I put in 1 for AB, right, you'd get negative 1 plus 1, and this would be infinity. And you would have an infinite amount of solutions, that meaning it won't be, this won't have just one solution. And if you think about it, if I put in any other number for AB, we will only have one solution because it's reduced to the reduced row echelon form. So in the end, using that concept in mind, you can justify that the only number that can't happen to make this inconsistent is if AB equals 1. So AB is your right answer. Look forward for the next couple of videos.